MK Technology, which developed the Cyclone, a complete rapid shell building system, has a new innovation. The high-speed drying tunnel for serial investment casting. Ceramic shells can now be produced continuously with a drying time of 30 minutes per layer. The usual drying period after the last layer can be omitted. In total, productivity is increased by a factor of 20 to 30. The tunnel is a modular system consisting of the central computer with control panel and display, the chain conveyor with continuously rotating hangers, and the drying chambers. Customer-specific production lines can be assembled with either straight or 90-degree corner modules. For easy and fast maintenance, the modules can be disassembled and assembled again in no time. The integrated sand separator collects loose sand and protects the cooling and drying technology against dirt. It's cleaned once a week in a matter of minutes. Normally the process is started with the production of the wax pattern and the assembly of the tree. Depending on the size and the geometry of the part, filled but also unfilled waxes are used. Besides the standard waxes, also normal water-based slurries and standard sands are used. With the exception of ethyl silicate binders, all standard materials used in conventional investment casting can be applied. After dipping and sanding, which is done manually as shown here, or per robot, the tree is attached to the conveyor. As soon as the number of layers and the drying parameters, such as humidity and maximum shell temperature, have been pre-selected, the first cycle is started. The door of the first module opens briefly and the tree enters the tunnel. As soon as it's inside, it starts rotating again and the pre-selected chamber climate is set up. A thermosensor controls the shell temperature, which is limited to a maximum 38 degrees Celsius. A video control system with several cameras allows for continuous observation of the tree during the whole drying process in the tunnel. The innovation proper, the high-speed drying of a layer in about half an hour, is based on three parameters: the infrared light, the highly turbulent and fast airflow, and the pre-dried air. All parameters have to be adapted to one another, and all of them have to be observed. Besides the extremely high time-saving factor, a shell which has been dried that fast has another important advantage. The number of layers can be reduced. The material costs can be decreased by up to 25%, and at the same time the permeability of the shell is increased. A shell with 7 layers is finished after only 3.5 hours. It can immediately be de-waxed and burned out. The casting and finishing of the metal part is also done in the standard way without alteration to the conventional ceramic shell process. All fusible metals can be cast, from aluminium and copper alloy to steel, stainless steel and superalloys. After the shell has been knocked off in large pieces, the rest is removed in a sandblast cabinet. If the system is running in 3 shifts per day, which means 20 hours, up to 60 complete shells can be produced. In the meantime, this new high-speed drying technology has been awarded the Success Innovation Prize by the Investment Bank of Rhineland-Pfalz, and a patent is pending. Several well-known investment casting companies have already tried this new technology, or indeed already put it into operation, and they agree that this new investment casting technology, developed by MK Technology, enables a tremendous increase in productivity while reducing costs at the same time.